So there won't be any quiz today, right? The reason is there was a break, and also I thought there's no sufficient content for us to have a productive quiz. So there's no quiz. For the following week, we can have a quiz, because then we have 2 weeks of discussion to create some questions, better questions, rather than asking about the history and all these things. Right. I think before we wind up last time, I gave you a question, right? I asked you to think about it at home and share the screen first. The question I asked was actually how to decide whether we have created an intelligent system, right? So that was my question. So to make that decision, we need to have some sort of a test, right? Now, as I said, there was a English mathematician and a scientist called Alan Turing, and Turing designed a test called the Turing test, right, for this purpose. So probably you read about it and you found some details about the Turing test. So the purpose is just to give you an awareness of what has happened in the past around this intelligent system domain. So basically what Turing said was, now suppose there is a screen, right? So there's a screen kind of thing. So behind this screen, there is a space for somebody to stay, right? So in front of the screen, you have an interrogator, somebody who is asking questions, right? So here you have a human, right? So this is a human interrogator, right? Human interrogator. So this person asking questions, right? Asking questions. Okay. So in Turing's design, actually, it is like written format. So you write something and you submit it, right? So write and submit in the sense text format, right? So in a, sorry, not written format, text format. So in the text format, you submit a question, right? So for example, what is the capital of Sri Lanka, right? So here you have somebody to answer that question, right? So when this human interrogator asks a question in the form of text somehow, right, the answer should come from this side, right? The interrogator cannot see through this wall, this screen. You can't see this, he or she can't see who is behind the screen and who is submitting or providing the answer to the question, right? Now, suppose if there is a human who is highly knowledgeable about almost everything, and that human can be there and be answering the questions of the human interrogator who is asking this question. At the same time, suppose there is a machine, right? I'll just draw it as a computer. So this is that machine. This machine provides the answers to this human, right? So in the modern technology, we can look at it like this. So you have, let's say you have a chat window, right? So on your screen, right? So you have a chat window, right? Through this chat window, you provide the chat message, right? There will be answers coming to this chat message. So those who are doing teaching, probably there is a program called Julia or something, right? So there's somewhere in 1960s, they had created a program like that. So I remember it was a kind of female name like Julia. I can't exactly remember now, just slipped through my head, but it's like that, right? So through this chat message, now you provide a chat-based question, and there should be an answer coming from the computer as a result, and that answer probably is right or wrong, right? Now, according to Turing, if the human receives that answer, and if the human cannot judge whether the answer came from a human or a machine, right? If this human interrogator cannot judge whether that answer came from a human or another computer, then if this is coming from a computer, then that computer is intelligent. Let's say this, here you have a computer, and the computer provides the answer to the human, and the human cannot judge whether it came from a computer or not, or a human, right? So in that case, Turing said this computer is intelligent. Okay, so now we are in now Turing died in 1952. Actually, he was forced to suicide. You can read the story about that, and that's also an interesting story why he was forced to commit suicide. It is said that the Apple computer's logo was designed based on that story, right? Those are all stories and those some interesting facts around that. But so Turing died before 1952. So he created this Turing test obviously before 1952. So after almost 70 years, right, or more, now we are in a better position to judge this test, right? So because now we are using chat windows, and we are chatting with chat bots, right? And we talk about things like RPA, robotic process automation, right? RPA. Now many companies, you probably have noticed that these kind of the minor versions of these kind of things are available on Facebook even, right? So when you go to that the page of a particular company, it prompts up a chat message, right? And you can chat with that system to some extent. If you go to the site of Dialog or something, there is a kind of a chat assistant, right? But you get crazy when you chat with those bots, right? So you can understand where they are technologically, right? So you can obviously judge that it is coming from a bot. Okay, so RPA, I must tell you, this is also an emerging area of intelligent systems, right? Now this stands for robotic process automation, right? Robotic process automation. Why I say this is an emerging area of intelligent systems, because nowadays many business organizations are trying to transfer or hand over repetitive interactions with the customers to software, right? For example, think about the call center. This is an example, right? So think about the call centers. If you look at the utilization of the call center staff, most of the times their time is utilized to answer repeated questions. That means many customers ask the same kind of question, right? So then your time is allocated, or your time is spent to answer those kind of repeated known questions. Whereas there can be customers who are actually needing in help, and also there can be questions of customers or problems that they are facing which needs the human attention, creative human attention. Then the call center staff finds less time to attend to those kind of problems, because their time is mostly utilized on this kind of repeated activities. So RPA is a good application in that sense. If you can hand over those repeated questions to a system, right? And then let the human operator attend to important questions which needs human attention truly. There you might understand, you might think, okay, now what is the that voice menu, right? So press 1 if it is Sinhala, press 2 if it is English, right? So there is also kind of an automation, right? So you try to automate that process and try to provide the answer to the human user with minimum involvement of call center staff, right? So this RPA is an extension of that. You try to make it more and more intelligent, so that it becomes a saving for the company, because then human operators either can be reduced or they can be utilized for better value-added tasks, right? There are many examples for robotic process automation. Call centers are one example. There can be many examples like voice-based ATM services, robotic process automation, inventory taking in retail outlets, right? So Zone 24/7 had a robot for that, right? That robot was roaming around the shop floor, right? Looking at the like items on sale. They're talking about clothing stores, looking at the items of this, so they can take the inventory, right? So updates on the inventory based on the information that the robot provides. So those are like examples for robotic process automation. You can read about it. This is an emerging area and probably a future like an important application area in the future. So there can be some employment opportunities created around RPA. And even now, many companies are focusing on this RPA. Right? So getting back to this Turing's question, right? Now, after 70 years, now we can see, we can re-evaluate this, right? In 1980s, there was another scientist called John Shirley. Shirley came up with a counter argument to this, right? Counter argument, okay. He said, here you have inside this room, right? There is a knowledge base, right? Knowledge base, which contains almost everything, right? It's a knowledge base, a very strong knowledge base, right? The task of this computer is then reading this text, right? Reading this text, interpret it, and submit the question to the knowledge base. Knowledge base submits you the answer, and it provides you, the human operator, the answer in text format again, right? You know, this Chinese text, right? So Chinese text has a reading, like voice reading, as well as a meaning. Every character, right? Every character, Chinese character, has a way of reading it, and also there is a single meaning for every character, right? So when you get a Chinese text, right? I don't know how to write Chinese, but let's say you have some sort of a Chinese text like this, right? So this has a meaning, this has a meaning, this has a meaning, and this has a meaning. So this could be a question, right? This is how Chinese is written, right? So if this computer can do that manipulation work, okay, it takes this one first, and then this one, then this one, then this one, make an interpretation, right? And submit that to this one. Then it submits you another string like this, the knowledge base, right? Then you arrange this into a human readable format, again through an algorithm by this computer, and you submit it, right? So Shirley's argument was this: if it was a human here, right? If it was a human here, the human thinks, right? Human thinks, and based on the human's thinking, the human provides the answer. If it is a computer here, Shirley said, you don't need that thinking. What you need is a sophisticated algorithm, right? Which can links you to a knowledge base, and from that knowledge base, you take the answer and you submit it. So there you are just an intermediary person. That computer is just an intermediary something, right? That was Shirley's argument. So he said, this is that he created an experiment called the Chinese room experiment, right? Chinese room experiment. Chinese room experiment, or Chinese room argument, right? So Chinese room argument says that, right? So if you have a knowledge base and if you have a strong algorithm, you don't need intelligence for that. It is just a matter of, you know, mapping, right? So you just map, you take the question of the human interrogator, you map it to the knowledge base as appropriate, and you get the answer, and then you submit it to the human interrogator. So it's not intelligent, as he said, right? So it was a counter argument to the Turing's test, right? So Shirley said, there can be two ways of getting the intelligence. One is true intelligence, right? Actually you think, right? The second way is you are pretending, right? You are pretending that you are intelligent, right? So as Shirley said, John Shirley said, the Turing test is not a test for testing the true intelligence, is it? It can be just passed, right? That test can be passed simply by pretending to be intelligent, like in the case of Chinese room experiment, or right. So these are interesting facts actually. These are actually philosophical level discussions, simple philosophical level discussions about this intelligence and true intelligence, right? So the bottom line of this, right? Bottom line of these things are, one thing it shows is how people thought about this whole field of intelligent systems, and they gradually, diverted their actions towards a particular path, the path that we are right now on, right? That is one thing. The other thing is, if we are to create a truly thinking, truly intelligent computer, where should we go, right? What are the things that we should focus at, right? It is obviously philosophy versus application. So for this artificial intelligence or intelligent system field to be useful to the mankind, then there should be some applications. There we cannot bother whether it is intelligent or not, right? Whether it is truly intelligent or not. So it is enough for us that it pretends that it is intelligent and it helps us with certain tasks. Last week we discussed about artificial weak intelligence or narrow intelligence. So narrow intelligence is like that, right? Narrow intelligence is like you don't bother whether the system is actually intelligent. What is important for you is that it's capable of doing something intelligently, right? It could be pretending that it is intelligent. We know that, but that's okay, right? As long as it is capable of doing it better than us because of the higher computing abilities that the computers are having, it is enough for us, right? So all these application areas of machine learning, robotics, right, and this various things are there, right? So natural language processing, swarm intelligence, right? So social simulation, all these things are application areas where these concepts of intelligent systems are applied in real world. So in that sense, that field has gone a long way, right? On the other hand, still there are attempts to create generally intelligent computer, right? Artificial general intelligence. So if you are to create a generally intelligent computer, then probably it is important for us to get into that discussion. From where are we getting this intelligence? If thinking gives us the intelligence, how do we think? From where are we thinking? Is it our head, right? Is it where we are thinking? Or is it just another organ or another component that helps us with intelligence? Where is the mind, right? Is it in the head or somewhere else, right? How mind is created? Okay, so if you are dead, if your brain is dead, is mind also dead, right? So mind creates thoughts, right? Continuously it creates thoughts. So is your head required always to control those thoughts, right? See the philosophical things behind that, right? So the science has created things, but still the science has failed to create a thinking computer, right? So probably a philosophical set of ideas would be required to create a truly thinking computer. I think in my opinion, it is very difficult to create a truly thinking computer because we are still not clear about how these thoughts are emerging, right? So what is the mechanism that we generate thoughts? Then it goes to a very extreme of philosophical discussions, which is not our interest, but it should not stop you from thinking. You just think about it, right? Now, if our objective is to create a thinking machine for us to get an intelligent system, a truly intelligent system out, we must understand how people think, right? So how are we thinking? From where do our thoughts come, right? Is it coming from our head or somewhere else? Then we get something called mind, an entity, which is named as mind, where we believe that our thoughts are coming, right? So where is this mind? Is it in our head or somewhere else, right? So then the role of the head and the mind. So then we lead to that mind-body problem. right? So famous mind-body problem. So read about those things if you are interested about these things. We will now continue our path towards the practical direction. Okay. Right. So if you have any questions, just post them as chat messages, then we can attend to that. So now let's think about something called nowadays when we are creating intelligent systems, we have a concept called agents, right? Agents. Now let me take the difference. So okay, let's say agents. Okay. Now we will try to understand this concept of agents. Now we say we are creating intelligent systems, right? Intelligent systems. So when you create an intelligent system, what is that thing, right? So what is that intelligent system? What is the best way of conceptualizing this intelligent system, right? Now, what is that? Is it like a information system? Is it something like Microsoft Word, or is it something like a web page, right? So there should be a structure for that, right? So some sort of a mechanism for us to understand, okay, this is our agent who is intelligent and who is doing this task on behalf of us, right? So that conceptualization is first required. In other words, you must look at the surrounding with a structure in mind called agents, right? So let's try to understand that. Okay, so this concept of agent it can be found even without this context of intelligent systems, right? For example, you have let's say you have a requirement. Okay, you are looking for a house, right, to rent. Okay, so and you are busy, right? So you can't keep searching houses for you because you are busy. You have your work related activities, family commitment, taking kids to classes. So you are extremely busy. You have your daily schedule is packed, right? On top of that, now you have got a strong need to find a house to stay because you have to move to a different place. Nowadays, people move to the city because of the transportation problem, right? So you are busy, at the same time, you need a house as well. Now, what should you do? One thing is you can set aside or put aside all your commitments and you can work on this finding a house, right? You take 1 week leave from everything and you commit for that. Or else you can look for an agent, right? A real estate agent. A simple concept of that is the concept of a broker, right? So broker is there to spend his or her time and money, right? And even efforts, and find what you are looking for. Camera is side of you, please move it. You mean to say this one? Okay, so just leave it. So don't worry about it. I'm not going to get it this time. Right. So you have a real estate agent, and that real estate agent is there to search for a house on behalf of you, right? So you give the instruction to the real estate agent, right? So when you give instruction to the real estate agent, the agent will act accordingly, right? And agent will go, right? So it will, the agent now we are talking about a human agent, right? So a broker, the broker will, have his own information sources and will take information from various sources, give calls to those required people and get some details about the available houses, right? And then look at a comparison, right? Because you have given the requirement, the specification. These are the things that I require and my budget is this much. So the agent will look for a house which is okay for your budget, right? And the agent is capable, the broker is capable of recommending a few places. Okay, this place is good for you, this place is good for you, this place is good for you. So you're kind of doing a recommendation, right? So based on those recommendations, now you can make a choice, right? Okay, we'll go and see these three houses, right? You as the human user can make a recommendation, can make a decision based on that. Now, is it clear what is the role of the agent? Right? Fine. If not, let me know, right? So now the broker, just think about a broker, and the broker is now ready to, broker gives you the answers to your questions, right? Now imagine on the internet, right? You have agents like that, right? So you like you can go to a site. Now you're looking for the same house, right? So you're looking for a house. You go to a house, you go to a site, and you enter the specifications. Now it's a real estate agent's house. Now in Japan, for example, these are very common, right? So in Japan, you can't rent a house freely, like freely in the sense like we do here. We can't. Now here it's like peer-to-peer, and like you go and talk to a landlord, and you get the information from the landlord directly, right? From your vegetable store or something, you see a notice, and then you call and you go to that place, meet the landlord, look at the house, and you get into agreement with the landlord, and that's done. In Japan, it's not like that, right? So you can't contact somebody personally and get into an agreement to lease a house, lease a property. You have to go to a real estate agent, give your specifications, discuss with the agent, and then only you can get it rented. But if it is online now, right? If it is online, the real estate agent can be a web page, right? Your problem is searching now. After getting it searched, after you are certain with that, then you can call the human, you can get the support of the human employee. So while you are searching, right? So you input your criteria, your details, and then you get certain search results recommended to you, right? So one thing that the recommendation can come in one way of getting that recommendation is, it is just a filtration mechanism, right? So it has a database, right? And in the database, you have the details of different properties. Then you simply write a SQL query, which matches the criteria that the user has entered. And then you get certain properties filtered out, right? But can there be some extra intelligence? If the profile of the customer is learned, right? If the profile of the customer, now I have a profile, right? So now let's try to see the difference, right? So one is, you as the user, you enter your specifications. You have a database where you have listed all the properties. Based on the criteria, you run an SQL query and filter out the ones matching with you, right? And then those are given as the results. That is one way, just a filtration, no intelligence in it, right? But when there is a human broker, the broker knows what sort of a person you are, right? Because broker can get to know the person. Okay, you are a person who is working there, and these are your requirements. You have these kids. This is your lifestyle. These are the things you like, and this is the type of neighborhood that you like. The neighborhood is like this. These are the type of people that you prefer to have in your neighborhood. By talking to this human user, the broker can get to know various things, right? So then if the broker matches the right property to the user or to the customer, only the customer will be happy, and the broker will be recommended to someone else also, right? So the broker's business depends on how well that match is done. It is not a simple filtration, right? It needs some sort of intelligence, right? So particularly about the neighborhood, for example, about the lifestyle and related things, the convenience, all these things needs to be judged and matched, right? So how can this perfect recommendation be done in a setup where there is no human involved, right? Can there be an agent who is able to predict which of the properties would be recommendable to this particular user, right? Now it is not a simple filtration. It is a recommendation. Filtration plus a recommendation, right? For that recommendation, the user's profile needs to be created. And that user's profile, it's like this. Person A, right, rented this kind of a property and gave 5 stars, right? 5 star. This star has to be like this, right? So, right, star rating I'm talking about, right? So gave 5 stars, right? 5 stars. So he was happy, right, about this property. Okay. Now this is you, person B, right? This is you. There is a sort of a similarity between the profiles of you and person A, right? You both are working for a bank. You both are middle-level executives. You both have 2 kids. Your wives are school teachers, like this, right? So, kind of similarity. Okay, similarity can be measured in various aspects, right? So these 2 profiles can be compared, right? And there is a property which is similar to this property as well in terms of various aspects. You can see how similar they are, right? And because this person liked this property and gave 5 stars, and because this property and this property are somewhat matching, and this profile and this profile are also kind of similar, you can confidently, with some confidence, you can say it is likely that person B is going to like this property. Okay. So this requires some kind of an intelligence if done at the human level, right? Because it is not a simple filtration. It could be a filtration, but it's a complex filtration, not a simple filtration as you can do using SQL, right? So this is an example. Now, who does this? Who does this matching? Who does this recommendation? There should be a software component, right? There should be a software component, right? There should be a software component, and the task of this software component is to find a property, right? To find a property which is likely to be liked by B. B is your current customer, right? Which is your current customer. Your task is to find a property which is likely to be liked by B. So that is a prediction. Prediction in the sense, you predict that this property is going to be liked by this person. What is the reason behind that? Reason is this property is similar to this one. This person's profile is similar to this person's profile. And because this person liked this property, it is likely that this person is going to like this. Okay. I was just explaining some sort of facts based on the details of recommender systems, right? Recommender systems. Right, recommender systems are applications of machine learning where you recommend products to users. If you go to Amazon, for example, there will be so many recommendations coming to you. If you are a regular purchaser, you're going to get recommendations, right? We recently did a project for one of the telcos in Sri Lanka to recommend telco products to their customers, right? So recommendation requires some kind of an intelligence, right? Intelligence in the sense, it is like pretending, right? So pretending to be intelligent, we know that it's not exactly truly intelligent, but we are pretending some abilities of humans, right? So humans are able to look at the profile of the customer, and based on the experience of that human broker, the broker can predict, okay, this product would be suitable to this person. Right? So behind the scene, then who is there? A software component. This software component requires an algorithm, right? This requires algorithm, right? Algorithm is a software program, right? Nothing else. So this algorithm should be an intelligent algorithm, right? Intelligent algorithm. Okay. So if it is a simple algorithm, then it is not intelligent. Let's think about that filtration, right? You have the data, you have a list of properties, you get the requirements from the user, you match it to that listed properties and filter the properties which meet the criteria. That's all. But a human broker is not like that. Uses more intelligence, uses past experience, and try to match the profiles and then find which property would be suitable to this person. That's a more intelligent decision. Can we make that kind of an algorithm inside our software component? Then it becomes an intelligent algorithm. Is it truly intelligent? No. Right? It is not truly intelligent, but it is pretending to be intelligent. Understood? That is actually data-driven approach. This, what I explained to you, is data-driven. That is actually in the context that I explained to you right now, in this housing context and even this Amazon recommender systems context, we learn profiles based on data, right? So machine learning is the core behind that. We have not discussed machine learning yet, but for your information, machine learning is behind that. What is the reason? This intelligent algorithm learns learns to make that prediction, right? Learns to make that prediction based on a large number of data that it has about the past purchases of customers. Right? It has very large amount of data about past purchases. Amazon, for example, it has a massive collection of data about purchases of customers. Right? From those data only, it learns the required pattern and get the ability to make a prediction about the items which are likely to be liked by a particular user. Right? So that intelligence comes from data. That is why you call it data-driven intelligence, data-driven approach of intelligence. Now, nowadays, what you can find mostly are the data-driven intelligence. Understood? Right? So, who is the agent here? This software component. Can you see that? No. Right? When you go to Amazon and when you make purchases, when you look for items, products, you don't see an agent there, right? So, but you get certain recommendations, and based on those recommendations, you can make a decision, right? It makes you to make decisions actually, right? In the context of recommender systems, like if this is what the user searches, right? What user search, right? This is what user search, what user knows, right? This, let's say this is everything on sale, right? This is everything on sale, and this is what the user search for, right? You can't recommend something here, right? You can't recommend something here to this user because it's far distant from what the user is looking for, right? There's no point of recommending this also, because then the user knows that the user needs. But if you can recommend something on the peripheral, right? Something here, this is something, a kind of a need that the user has, but the user has not actually figured it out. Or probably user has forgotten, I need that one also, right? I had forgotten, lucky that the system could recommend it to me. Then the user, get engaged to the system. Right? If you recommend something which is far distant from the current need of the users, then that is not an effective recommendation. Right? The effective recommendation is recommending something closer to the user's current requirements, like peripheral recommendations, which the user has still not figured out. Then the user will become happy. The system recommended this to me. Lucky that it recommended to me. So otherwise I could have forgotten that. I didn't think about it. It's actually useful to me, but I didn't think of it. I didn't know about it. Right? So effective. So that is where the intelligence is required. Right? So otherwise, it probably could be a simple filtration, simple profile matching. So somebody which is similar to your profile, all of a sudden had decided to buy this, which is not in your priority list at all. Right? It's not an effective recommendation. An effective recommendation would be something that you have not figured out yet, but the system could figure out before you, and it has recommended it to you. So you become sort of delighted that you have found it. Right? So you don't see the agent here. right? But there is a structure for that agent, right? There is a structure, okay? So if you see this agent, right? Agent like this, there should be a environment, right? There should be like this, right? There should be an environment, right? An environment where the agent is operating. In the context of Amazon agents, there is an environment, right? It has a large product pool, large customer pool. So the data, right? Data it has, it's there, it's the environment, and the user is also operating in the environment, right? The user, the products, and the previous users, everybody is in its environment. There should be a mechanism for this agent to get inputs, right? Inputs from the environment, right? You get some inputs from the environment, right? There should be a set of actuators, right? Right. There should be actuators which enables this agent to act on this environment, right? So these are like, you need sensors, right? You need sensors to take inputs. You need actuators to take to act on the environment, right? So actuators enable the agent to act on the environment, whereas the sensors enable the agent to take inputs from the environment. Okay. Now the question is, what are these sensors? What are the actuators in the context of our recommender systems? Right? In the context of the recommender system, we need to have ways and means to get the information from outside. Outside in the sense our environment, right? So since it is software based, and we are purely a function, right? So our agent is either a function or a collection of functions, right? So inside this agent, then, right? So in software, if it is software component, inside this there is something called agent program, right? Agent program. Right? This agent is actually an agent program, nothing else, right? So inside this, it has functions, certain get functions, get something, right? So get this information, get that information, right? Right? Get this information, that information. So you have a function, right? So from that function, as parameters, you get the details, right? There should be a function to load the data, right? There should be a function to get the required information from that required columns from that data, right? And so as actuators, right? Actuators like display, right? Display functions, right? These are not concrete, right? So just examples, right? So displaying or print functions, so the printing the recommended items to this particular user, right? Display or print, right? So through the display function, you send it to the interface for that to display. Okay. And also your recommend function. Recommend function, I just wrote only up to this point, right? So it's like recommend, right? Recommend function. So recommend function contains what? This intelligent algorithm is there in the recommend function. Okay. So a software agent has a structure as well as a program, right? A program is the intelligent algorithm which helps it to make an intelligent decision. It is embedded to that structure. In the case of a software agent, the structure is nothing but a set of functions which are designed to get the desired output based on the inputs. Inputs are considered as coming from the sensors. In the case of software agent, you don't have physical sensors, but you have just another function. In the case of actuators, actuators are required for it to act. In the case of a software agent, like what I explained, it is a set of another function, right? The actuator is just displaying, nothing else, right? You display what are the recommended items. Understood? So there can be other functions as and when as required or as appropriate. But what I explained was something for you to understand. Now, if you have questions, now it is time for you to ask. I explained you the concept of agents and a software agent. Okay. Again, I kindly request you to put public messages, then everybody learns. This question is there a difference between artificial intelligence versus artificial general intelligence? First of all, in your question, you have typed as artificial intelligent, right? That is not correct. Artificial intelligence, right? Artificial intelligence. And you ask whether it is artificial intelligence versus artificial general intelligence. There is a difference. In fact, artificial general intelligence can be considered as a subset of artificial intelligence. When you say artificial intelligence, it is a broad field of study which includes artificial weak intelligence or narrow intelligence, artificial general intelligence, as well as artificial super intelligence. Those are three different paths. Researchers are going along all three paths. Right, all three of those paths researchers are going along. So you can say artificial intelligence is a general term which encompasses all those three pathways. So general intelligence is just one branch. Okay, right. Yes. So in Facebook, I'll give you an example. So when I was about to return to Sri Lanka from Japan, my daughter was small, like 4 years. Yeah, about 4 years. So I was continuously purchasing toys for her, right? So since it was girl toys that I buy, so most of them were pink, right? So various pink cars, pink bicycles, and those kind of. I was collecting those toys for her because I was under the impression that the quality of the toys are good when it comes to Japan. So I was collecting some toys. I was planning to send them to Sri Lanka as a shipment before I come. Shipment is not a big shipment, but like a package, right? So I was planning to ship them after collecting, right? I did that actually. So because I was continuously purchasing on Amazon, I was buying. So because I was continuously purchasing, somehow the advertising system behind Facebook had figured it out, and it started displaying all pink toys in my right hand corner, right? So on the screen, when I go to Facebook, whenever I go to Facebook, I can see a lot of pink toys being recommended to me, right? I had never purchased on Facebook, right? I had purchased only on Amazon, but somehow it had figured out that I am a person who is purchasing girl toys, right? So in Facebook, ads were popping up. So probably the Amazon system, right? So Amazon system is feeding advertisements or recommendations to my Facebook profile. Yes, as you say, it is an intelligent algorithm. So that sort of intelligence is working now. But it is again, it's not actually a true intelligence. It is like data driven. So if we have massive pools of data, then it's just a matter of recognizing patterns from that data. Anything else? Right. Now let's extend this discussion to another context, right? So we were talking about software components. How about hardware, right? Hardware software combinations. Now you are learning IoT, right? So you're learning IoT. In IoT, you have sensors and actuators, right? You talk about sensors and actuators. You create systems, smart systems, I would say, right? Using IoT, you create smart systems where you take information from the environment using sensors, and you act on the environment using actuators. right? So let's talk about that context for a moment, right? So something that I am interested these days is smart agriculture, right? Smart agriculture. So something I am interested particularly because uh, now the government talks about this home gardening, right? But this, in most of the cases, I think our people are not aware of gardening, even though people like I like it, but I know many people like it. Now, when all of a sudden government says there's a kind of a food shortage coming, and you must plant in your home garden, right? Most of the people are clueless, and sometimes it does not match their lifestyle, right? So yesterday I was listening to one of the politicians saying the doctors, how can the doctors do home gardening because they have other profession, that is where they are trained, right? So in a way it's true, right? So you are not, that is how this society is organized, right? So social structure and everything is organized around some specialization. You are a doctor, you are specialized at that. You are a farmer and you are specialized at that. So as a doctor, unless it is your hobby, can't do home gardening just to feed yourself when there's a shortage. So there is a problem, right? So what I'm thinking is, now I'm not saying smart agriculture is a solution for that, but smart agriculture and precision agriculture, it has a lot of use cases in mass scale production, right? To produce a lot. But in case of this home gardening also, this smart agriculture can be practiced by people like you and me, because we are aware of these sensors and actuators to some extent. We know programming a little bit, right? We can read and understand a bit of electronics, right? Can create a simple prototype using Arduino board. So why not we put it into practice, right? The problems like this, problems like what we are having these days, it gives us innovations, right? So that is why we are here, right? So as educated people, uh, somebody was telling yesterday, when you say educated, it is wrong, right? So educated means you are done with your education, right? So when you say educated, it doesn't mean that you are capable of doing anything, right? So but if you are a lifelong learner, then you are not educated. You can't say past tense, right? You are learning, right? So rather than saying educated person, you can say you are a learning person. So as learning people like you and I, can't we put these things that we discuss into practice at our homes, right? Now I see the smart agriculture as one of the beautiful use cases that we can develop, right, to test what we have learned in the class, right? So for me it is interesting. I'll tell you what I'm thinking of. uh, Now I am interested in I'm an educator, right? So I'm interested in transformational learning, right? Transformational learning, which means I'm thinking about undergraduates actually. So these are just background information, right? So just to tell you that these intelligent systems are not distant from us, right? That is my objective of telling these stories, right? So these are our day-to-day stuff and things that we can practice our homes based on the things that you even know now, right? That is what I'm trying to say, right? So to show you that there are enough use cases around us to apply our weak intelligence, right? Rather than thinking of this bigger and complex scenarios, let's try to be very simple and try to do something, right? At least we will fail, but that through that failure we will learn something useful for us to apply in our next encounter, right? So I'm interested in transformational learning. Transformational learning means now it's like converting people to lifelong learners, right? So we have to start it at the undergraduate level, because the undergraduates are, let's say, the first year students who are coming to the university, they are just 19, 20 years old. They have spent most of their time in tuition classes. There are people who are doing tuition here, bear with me, right? So I'm not criticizing you, but the model of tuition is what I'm criticizing, right? So it's like passive learning, right? So in fact, what I'm doing right now is also passive learning, but I'm just trying to show you some active learning pathways, right? So bear with me. I have to uh, do this passive learning because we are compelled to do all these things online. If it is offline, I could have done this in a different way, right? So transformation learning, in passive learning, what we do is the teacher tells you everything, you by heart, and you answer to the question. To a large extent, that is what you and I are also doing, right? But the real concept at the university should be different, right? So our objective is to convert people to transformational, to lifelong learners, right? That is what we call transformational learning. So I'm thinking of using this smart agriculture as a means of doing this transformational learning, right? Just imagine, right? Just imagine now you are learning intelligent system with me, networking you did. You are also learning information systems with Dr. Ruan. You are learning IoT with Ms. Daraka. So where are you going to put this into practice, right? So with Dr. Ruan, you are learning that everything is transforming digitally, right? Everything we do is transforming digitally. And probably you have heard of agriculture. Somebody asked me that question, even, right? So industry 4.0, agriculture 4.0. So you learned about that revolution in agriculture, revolution in industry, right? Revolution in health, various domain, revolution in education, and in every domain now you are transforming yourselves, transforming the practices digitally, right? So which means that we need to adapt technology to transform our world. Actually, we not that we are doing it deliberately, it is happening, right? So we are converting everything into digital form now. Education transformed to digital, agriculture transformed to digital, right? So we know that it is happening. With me, you are discussing the concept of intelligence. And now you know that artificial intelligence is not a big thing like rocket science. It is something that we can adapt to our day-to-day lives. That is what I am trying to communicate to you, right? So with Ms. Davaga, you are learning that there are certain equipment which can be connected together and controlled, can create some systems, and you can control those systems remotely using your mobile phone, for example. You can monitor the status of those systems remotely using your mobile phone. You can send that data to a cloud system and let the data to be stored there, right? You can see that you know that you can see that you can create some sensory motory systems where the sensors collect the data and put that into actuators. So let that actuators to function on something, right? So that hardware software combination you are learning, and the ability of creating smarter systems, right? What I'm thinking is, if I let that atmosphere, right? If I create that atmosphere at the university, right? So that the students can freely, right? So you, for example, can come and do some experiment. You are in need of creating a smart system, right? So you like agriculture, you want to try out, right? You want to control an exhaust fan using a temperature controller, right? Inside an appropriate setup. So what I'm thinking of is providing that atmosphere. I'm trying to do it with the help of Dr. Shanta. He's the coordinator of the HEAD project. So we are trying to provide that kind of atmosphere. Unfortunately, very unfortunately, the situation of the country is not supporting, right? So the first thing that we are conceptualizing is to set up a greenhouse at the rooftop, right? So inside the greenhouse, we can set up a hydroponic farming system, right? If you don't know these things, read, right? So they are really interesting, right? So hydroponic farming system, hydroponic means you're growing plants on water with some nutrients mixed into the water, right? So the water continues to flow through a tube, and you have set up your plants on that tube, and the plants grow, right? That is a basic form of it. Now you have several sensors: pH sensor, EC sensor, temperature sensor, moisture sensor, light sensor. All these things are there, right? So can we make that growing system smarter, right? So that is the part of the student. So imagine a first year who is coming to the university expecting to do IT here, is put into that environment and given an awareness of those equipment and components. Okay, you go and set up this, right? You convert this into a smart farm. That is the transformational learning that we are expecting. For you, even you can apply that. Since we can't do that in this online space, I am telling you to practice at home, right? Read about hydroponic farming. You can't, the greenhouse is expensive, right? According to the current prices, with the information that I have got, it requires around 175,000 rupees to set up a small scale greenhouse. It is expensive, but still think about indoor farming, right? So light controlled farming. There are grow lights to purchase on Amazon, but you can't buy it here, but you can create something similar using some LEDs, right? Do some experiments, see whether tomatoes can be grown in-house, right? Control the light so that it's the precise amount of light can be decided by the system by itself, right? So always apply what you are learning in IoT to a use case. My use case is smart agriculture, and see whether you can apply the things that we discuss in the class into that, right? In a way, you will be like thinking of this home gardening in a different way. In another way, it probably will take you to entrepreneurship, right? It is nowadays, there are people called agripreneurs. Agripreneurs means entrepreneurs in the agricultural domain, right? So it's a massive field actually, right? So there are people who are doing these kind of entrepreneurships in the field of agriculture these days in Sri Lanka with the help of YouTube view, right? Study those things as well. Anyway, so we'll discuss a small use case in this smart agriculture domain, right? So if you want some additional vocabularies, you can, as a general term, you can talk about agriculture 4.0, precision agriculture. This is like optimized method. Like for example, some plants requires precise amounts of nutrients and other parameters, light and everything. So how can you control that parameters precisely is a question, right? So precision agriculture can be done with the help of intelligent systems and IoT, right? So there's another concept called vertical farming, right? Vertical farming. To do vertical farming, you don't need electronics, but with electronics, you can do vertical farming in a better way, right? For example, if you don't have space at your home and if you only have a balcony, right? So how can you get a bigger space for you to grow multiple plants, right? That is vertical, right? So rather than horizontally farming, if you have a large land, why not you go vertically? And then there's a way of going vertically without electronics even, like you grow in those let's say pet bottles and hang them on the wall. That is also vertical, right? At the same time, you can have layers of racks, and on those racks you keep pots, and you control those nutrients and other parameters using electronics. That is also vertical farm, right? So these are around this. You have an hydroponic farming. This is I'm not a agriculture expert. I'm just an enthusiast of this. So I'm trying to build up a use case around this for transformation learning. So I'm giving this information to you for you also to think, if you don't know already, for you also to think and apply these things at home so that you can put certain things into practice rather than become mere passive learners, right? So hydroponic farming is one of the problems that you have, that students have, not students, people have when they try to do farming at homes, especially if they have limited space, is soil, right? If you don't have soil, then your plants will not grow properly, right? Sometimes soil contains different bacteria and other kind of funguses So it does not give you the right harvest. So hydroponic farming is a solution for that. You don't need the soil. You can grow on water. Right. So these are the basic information. So on top of this, think how your IoT knowledge and this intelligent system knowledge can be applied. Right. So that is your use case. Okay. Right. So we were talking about agents. Let's try to understand this agent, the concept of agent using this bit of agriculture. Right. So if you have a, let's imagine you have a balcony, right, and you are growing tomatoes, right, on your balcony, not in a hydroponic system, but in the aquaponic way on soil, right. So you have a tomato plant, right, on a pot, right. So this is your tomato plant, right, and this is grown on this pot, right. I'll first explain the manual way, and then the IoT controlled way, and then the intelligent way, right? So this is your balcony, right? So this is your balcony, and every day you must water this plant because you know, without water the plants on pots can't grow. So unless you get rainfall here, rain falling on the plant, you can't expect water to stay here, right? So it get dried off very often. So every day you have to pour water into this pot, right? Now imagine you are a person, you are a banker, or you are an executive at a private organization, or even a government employee, right? So you like farming, you enjoy this hobby. So you are a busy person. So you sometimes you tend to forget these things, or sometimes you remember, but you can't practically pour water every day. So what do we require? What do you require? You need a system, right? Automatic system to put water into this, right? One thing you can do is a drip irrigation system, right? So you have a tap, right? You have a tap, and from this tap you have created a system to, yeah. So one thing you can do is a drip irrigation system, and you can put a timer here, right? If necessary, you can put a timer here or wherever, right? So you can put a timer. The timer can control when to put or how long should this be function, right? That is one thing you can do, right? Let's say you want to have a better control over this system, right? You need to have a better control over this system. Then what you can do is you can set up this, I can't remember that valve's name, right? So that valve can be connected with this, and that can be controlled smartly using IoT, right? So what you require is, now you don't want to waste water also, right? So you put a moisture sensor here, right? Yeah. So you decide the sensor, right? So you know this sensor, so you decide the sensor. I'm just explaining the use case, right? So so from this moisture sensor, you get to know the moisture level, right? You get to know the moisture level, right? And according to this moisture level, then you control this valve, right? And let this irrigation system to function, right? Then you put the water into this, not based on the timer, but based on the valve, right? So based on this, sorry, not the valve, based on the moisture level on the soil, right? So moisture level on the soil controls the, sorry, is read frequently, and if it has gone beyond a particular threshold, then you pour water into this, right? And if you can, if necessary, you can monitor using your smartphone, right? Is this intelligent? Right? Is this, I'm just explaining a basic use case, right? So you just feed the moisture level of the soil, and according to the moisture level, you actuate, right? Actuate a valve, and that valve let this drip irrigation system to function, right? Now this is the use case. Okay, my question is whether this is intelligent. It is not, right? So it is not there's one yes answer, right? Maybe narrow, right? So why do you say it is narrow intelligence? Is there a decision made, like you can say, you can put a threshold here, right? A decision threshold, right? So it's a simple program, isn't it? Like if the moisture level M greater than the threshold, activate, let's say, not activate, open valve, right? Open valve. Okay, so this is simple algorithm, right? So if it is greater than a particular threshold, you open the valve. Is it require any kind of intelligence here? For example, how much should this valve be open, right? So how much flow should be given, right? Flow control, for example, right? So sometimes it needs a bigger flow, maybe not in this case exactly, but maybe a bigger flow or a lower, a smaller flow, right? How much flow should be given to this particular scenario, right? For example, after power outage, now your plant is highly dried off, right? So you need a higher flow quickly, right? Or else now the moisture level has slightly gone down, so your flow can be small flow, right? So how much should this be controlled, right? This amount of water to be poured within a minute, right, can be controlled, should be controlled, right? So that is what you call intelligence. Okay, so if you are a farmer, you look at the plant and you say, okay, this needs a lot of water, right? So you put a lot of water there. But this time when you look at it, you realize that it does not need much water, but a bit of water is enough, right? So water amount should be decided by the system, amount of water that needs to be poured in a period of minute, for example. I'm talking about the control of that drip, right? So to create that kind of a system, this sort of an algorithm is not sufficient, right? You must decide how much water to be put into this. What is the speed of the flow that you must maintain at this particular moment, right? In a way, you are saving water as well, because you don't want to let water to be wasted, right? So you are saving water and you are providing only the precise amount of water required by the plant. Extend this use case to a different scenario, like you have many plants like this. Different plants are operating with different parameter conditions, and now you need different amounts of water to be supplied to different plants in a given situation at a given moment. So how do you make that control, right? Clear? So in my opinion, this particular scenario that I explained right now, what you can see on the screen, is not intelligent. It is just a simple logic, right? Simple condition. It works according to that simple condition. But if you extend that to what I explained after that, like precisely deciding how much water to be released to that plant, right? Then you need to decide how much to be released. To decide how much to be released, then you need a little bit more intelligent, higher level of intelligence, right? So if you look at techniques like fuzzy logic, we will be discussing fuzzy logic. Right? Fuzzy logic. Fuzzy logic, thank you, right? So you understood, and thank you for telling that. So fuzzy logic helps you. Now this is actually a scenario like this. Now imagine there's a farm. Now think about the way farmers make decisions, right? Today it's like really hot, right? Very hot. So I must put more water, right? Linguistic decisions. The farmer does not say, today the temperature is 35 centigrade. and I must put 2 liters of water to this particular farming bed. So that's not the way of making decision, right? So linguistic decision making is, today is very hot, I must provide a lot of water. Today it's raining, so I should not provide much water, right? Look at the way of making decision, difference, right? Look at the difference. In the first example, it was using crisp values. Crisp value means the numbers, right? Today the temperature is 35 centigrade, so I must provide 2 liters of water to this. Next example is, today it is very hot, so I should provide a lot of water, right? So when you say, now that is the farmer, right? So if you transfer, actually speaking, that is the second scenario is what is closer to the human decision making. If you want to make a system like that, right, which is not functioning based on precise numbers and working with precise numbers, you need precise numbers actually, but the decision is made not using precise numbers, right, based on linguistic variables, right? Very hot, moderately hot, mild, cool, cold, right? So you make decision based on those kind of linguistic variables, right? So if you want to create a system that mimics that pattern of human decision making, right? So you need something like fuzzy logic, right? Then you say, okay, today is very hot, so I decide I put lot of water to this plant. So what is this lot of then? How can you give that message lot of to the drip irrigation system? Then you need a way of converting that into a number, right? That number will be precisely corresponding to that decision of lot of. Okay, you may not understand it right now, just try to get a surface level understanding, right? Surface level understanding only. After that, when we discuss fuzzy logic, you will understand, right? Okay, so that is why I say this is what I explained. What you see here, right? What you see here is not intelligent. It is just a simple IoT, right? Sensory motory system. But that sensory motory system can be made intelligent, right? For that, you need an intelligent algorithm. Now the question is where the agent is. Where is this agent? Right? Now, suppose you have a helper at home. You tell the helper, while I am not at house, you must water this tomato plant. Agent. Right? You don't have a human helper, but you have a smart system. That drip irrigation system, right? Timer control drip irrigation system. Again, an agent, a mechanical agent. Right? You have a smart IoT system. That is a smart agent, right? Smart IoT system to do this watering process. That is a smart agent. You have a smart IoT system embedded with fuzzy logic system. That is a smart intelligent agent, right? Do you see the application of agents? So wherever we apply these kind of things, you are supposed to have an agent. So agent is nothing special here. Agent is a way of conceptualizing your intelligence system. In this case, our agent has physical sensors, physical actuators. What is the physical sensor? The moisture sensor. What is the physical actuator? The drip irrigation valve. Sorry, the control valve. So valve is what controlled by the system intelligently. Right? The valve controls the flow. Right? So, so this agent is everything, right? So this sensor, actuator, plus the agent program, the intelligent fuzzy logic based program. Be careful, fuzzy logic is not the only way of making that agent intelligent, right? So there can be other ways as well. Now what I'm inviting you to do is to read about this smart intelligent agriculture and try to see what are the possible ways of making your smart agriculture system intelligent. You will see a lot of use cases there, right? For example, in Singapore, there are smart farms where you collect a lot of data, and based on the data gets into a cloud, and from the cloud the data is processed, and then the parameters are controlled accordingly, right? So it is costly, but you need to put an investment into that, but at the same time the harvest is also high. So that is where agriculture technology is, I mean, that is agriculture technology, agriculture 4.0, right? So there are massive use cases around this, but at our homes, what we can, based on what you know, right, and what you learn, what you can do is to create simple prototypes. If you have kids at home, like there are some students who are with somewhat grown up kids, like 12 years old, right? So this would be like interesting thing that you can try out with your kids, right? Because that's the next generation. So we must create these kits to with some sort of ability to use some tools. For example, I personally don't have that ability, right? So it's some kind of a something that I regret about, because I should have had that ability to work with tools like grinders, drills and all these things. So I must learn these things by myself now, right? So now it's too late actually. Right? So, but if you have kids at home, give them that practice. Safety should be first, but with safety, try to give them that practice. At least let them see you are working on that, so that our next generation would be doers than followers. They will do, right? Anyway, so this is an explanation of agent, right? So agents, again, what I wanted to say was, don't look at this agent as a very sophisticated thing, right? The concept of agent is very simple. Okay, you can create a human, you can have a human agent, a mechanical agent, a smart electronic agent, a smart intelligent agent, right? And how, to what extent is that agent intelligent is a different story, a second story. To what extent? But still, there can be simple intelligence, there can be a somewhat complex intelligence, so advanced intelligence. So it's up to you, right? And it depends on the use case. To a use case where you don't require a lot of intelligence, there's no point of talking about sophisticated intelligence, right? Now, a popular example is this. You have this conceptualization, right? So you have a vacuum cleaner, right? This vacuum cleaner is a kind of automatic vacuum cleaner. The vacuum cleaner can sense the dust level in this room, right? Okay. If the dust level is above a particular threshold, the vacuum cleaner operates automatically and clean this house, clean this room, right? If it is clean, then it moves to this room. There are only two rooms, right? It moves to this room. Then again, it cleans up, it checks the dust level, and if the dust level is high, it sucks the dust and cleans the room, right? If it is clean, it moves to this room. So it's like moving back and forth between these two rooms, and your task is cleaning, right? It's a simple agent, simple reflex agent, as we say, right? So that agent's intelligence is minimum intelligence, right? It actually speaking, it is like this, right? So you show some kind of intelligence there, but it is not actually intelligence, a simple algorithm, right? But your sensory motory system is there to sense the availability of dust. There should be a mechanism. So to actuate by sucking the dust in, you need some sort of actuators, right? So that is your sensory motory system. Your sensory motory system works pretending to be somewhat intelligent because of the ability to sense information from the environment and put that into an action. Is it truly is it intelligent? Well, no, it is not actually intelligence. But because of your automatic nature, you look to be intelligent, right? So if I take you to, there are a bit of theory around this, but this is not, I don't want to spend much time on these theories. because I don't want you to buy hard these things, right? So this is what I explained now, the using this vacuum cleaner example, right? So simple reflect agent is the agent takes action purely based on the current environment state, right? Current environment state. So it's like you sense the dust level, and if the dust level is above a particular threshold, then you suck the dust and clean the room. Then you move to the other room. Again, then if the dust level of that room is beyond a particular threshold, you suck it and clean it, right? So limited intelligence, the environment has to be fully observable. Now this is an important concept. Fully observable environment, right? In our drip irrigation example, and even in this case, we say that our environment is fully observable. Because of our moisture sensor, we can get to know the moisture level precisely, right? Because of the dust sensor, like imagine there's something like that, right? So dust sensor, you can sense the dust level of the room, and you can make your decision accordingly, right? So there are situations like that where your environment is fully observable, right? So when the environment is fully observable, the amount of intelligence you require is also less. What is the reason for that? If the environment is fully observable, the uncertainty, right? Uncertainty is less, right? Your uncertainty is less. Okay. Because of that, you don't need much intelligence, right? You can be pre-programmed, right? But there can be situations where the uncertainty is gradually increased, right? So there's a concept called partial observability, right? Just imagine your vacuum cleaner agent is designed to learn its environment, right? For example, because if it is a vacuum cleaner and if it is a commercial product, then you can't expect that to be functioning in the same kind of setup in every consumer's home, right? So in your home, the room arrangement can be different from my home, right? You have some number of bedrooms in different floors, and I also might be having some number of bedrooms in different floors, but their arrangement, their layout is different. So you can't expect your agent to be fully observable about everything, right? So you need to allow some partial observability to some extent, right? The vacuum cleaner I brought and the vacuum cleaner you brought should have the ability to have a model of the layout of the house, and then only it should function, right? So we can provide a model to the agent. Okay, this is the environment that you are going to operate on, right? So we provide it a model. Okay, this is the environment that you are going to operate on and work on this environment. So the vacuum cleaner I brought will operate on my house layout, and the vacuum cleaner you brought will operate on your layout, right? What is the concept here? We provided the model of the house, and accordingly it will act, right? So it has to have a model. What is the world? What the world is like now, right? So when you take home your vacuum cleaner, it must learn its environment. And when I take home my vacuum cleaner, it must learn my environment, right? So how do we enable it to do that? We provide the model of the environment to the agent. So the agent is capable of learning the model. And some agents are going beyond that. It can, can learn its model, right, by itself. I just imagine a game, right? A combat game, right? In the combat game, you are fighting with different opponents, right? Now, our combat games they are intelligent actually, right? So you are fighting with a character, and that character learns from your moves, right? So now how can it learn those moves? It has to have some sort of a model in, right? So it learns those that particular world, its world. It knows how to avoid obstacles, right? It moves by avoiding obstacles. So how does it do that? It has a model in it, and it updates that model frequently, right? So you have an internal model, right? How about you as a human being? How about you? Do you have a model in mind, right? To operate in your house, you have a kind of model in your environment, right? When you go to a new building, right? When you go to a new building, your knowledge about that model is minimum, right? But still you are able to, figure out that model eventually when with your experience. Okay, you roam around, then you see there are doors and rooms like that, and which rooms are which rooms are allowed for you to get in, which rooms are not allowed for you to get in. So you get to know about that sort of a model, right? Then only you act on that. You don't think about getting into the rooms where you are not permitted to enter, right? So that is the model. You're updating your model. So you're updating your model, you're eventually learning the model, and then you become an expert of roaming around in that building. So that is the model-based agent. So how these agents learn the model? Now it must be your question, right? So reinforcement learning. I don't think we have time to get into this reinforcement learning context, but reinforcement learning is an interesting, I'll show you something, right? Actually, this is a walking robot, right? This is a walking robot. This robot, these are 4 actuators, right? At first, this fellow even does not know the existence of its limbs. I mean, it does not know that it has 4 legs, right? That is the beginning. So eventually it learns that it has a structure like this. Eventually, right? Eventually it learns a structure after several, attempts of, after several wagging of its limbs. Like a child, for example, a child, when it is born, the child does not know that it has 4 legs. Sorry, it has 2 legs, 2 arms, right? It doesn't know. Right? The shape of the body, it's unknown to the child. So child is just waving its limbs and trying to get some kind of an idea about its environment, right? So after a while, the child learns to get on its chest, right? And then still try to do some movements. And then after a while in the sense, after some time, it learns to lift its head, right? So lift its head and then start crawling and then standing up on its feet, right? So what is it doing? What's the child doing? It's like learning the environment, learning the model, right? Learning the model and model of its environment, his or her environment and own body and all these things to try to learn a model, right? So this robot is also like that. It eventually learns that it has 4 legs and then learns to walk like this. So check videos on reinforcement learning, then you will see how reinforcement learning gradually enables these agents or robots to learn its environment and its own capabilities. The next thing is utility-based agents, sorry, goal-based agents. So these agents, I'm going to give you a small exercise for you to get an idea about these goal-based agents now, after this, right? So agent needs a goal to function, okay? So in a different scenario, for example, my objective is of this agent is to move from one place to another, right? You need a goal, okay? Reach this goal. There are such agents, right? And utility-based agents, we will discuss about these utility-based agents when we talk about genetic algorithms, right? Right. If you have questions, just put them as chat messages. Let me ask you, let me explain you a problem for you to think, right? Now we have some childhood games. right? So now forget about all this IoT, right? So that discussion is over. But I invite you to practice with this IoT and try to think how those systems can be made intelligent, right? My opinion, right? When you try these Arduino based exercises, most of those things can be found on YouTube for you to practice, right? So as master of IT students, your objective, your in the back of your head, what should function is, why are we learning these things, right? So you will be introduced to various, I'm sure the lecturer will be explaining these things, but my opinion, right? So the existence of sensors, existence of actuators, the ability of connecting those sensors and actuators and putting that into a system, and those things you need a basic introduction. That basic introduction you can get by attending the lectures and also by watching some YouTube videos, right? But your target should be to see where these things can be applied, and you must create innovative prototypes. That is my interest and my advice and my opinion, right? You must try and create some innovative prototypes using those things. There are enough problems that can be solved and that can be attempted to solve using those sensory motory systems, right? So see those problems in your surrounding. This agriculture is one thing that I see, but can be many, like in education. Can you do these things, right? Can you recognize the facial expression of the student while learning and see whether that student needs help, right? And see whether that student understood, right? So these are just examples, right? So using simple cameras and all these things, you can try to see the facial expression of the student, right? That is also IoT, right? So camera gives you the sensory input. There can be actuators. I don't know what is that actuator, but actuator could be a software-based assistance to the student, right? So see, just try to see how these smart intelligent systems can be created with the help of that you learn, the knowledge that you gain in your IoT lecture as well as this intelligent system lecture. The information system module will give you use cases. Right? It will tend, so what I believe as master students that you should do is to see the connectivity between the three modules as well as the previous modules that we learned, to see the whole, because at the end of this trimester, you qualify to become a postgraduate diploma holder, right? So as a postgraduate diploma holder, now you should be able to put certain things into practice, right? That is my expectation as an academic, and also I think that is the expectation of the program, right? So continuously think about it. Now let's understand, let's do a simple exercise. I'm going to take you to the concept of search, actually. Search, right? SEARCH, right? Search. So concept of search. So searching is an important activity in intelligent systems. That is one of the basic and one of the earliest attempts that people made to create advanced search, right? So some people say this is not intelligent, but this could be considered as a beginning of artificial intelligence. So early artificial intelligence systems were functioning on search. At the same time, if you take modern artificial intelligence systems like these sophisticated games, right? These games use these advanced search techniques, and even these things like Google Map, for example, right? So it gives you the optimal route, right? Optimal route to to take if you want to move from A to B. So when you look at that optimal route, so when you get that optimal route, just imagine how many possibilities could have been there, right? So if you look at Google Map, like this, like a connection of dots, right? So between these dots, there are enough roads, right? So map is like that. Okay. So out of all these possible combinations, your Google Map tells you, okay, take this path. This is the path that you should take. This is your optimal path. How does it give you that information? In no time, in a fraction of second, it gives you that answer. It is a search, definitely a search, but it is an optimal search, right? Out of many possibilities, a large number of possibilities, it gives you precisely, this is your shortest path. This is your fastest path. It's a search, but it's an intelligent algorithm. It's a narrow intelligence. So we are thinking about this kind of a context, but let's start with simple things, right? And it requires some ideas about this computing as well. The use case I'm going to give you is, we have childhood games, right? Let me explain a childhood game to you, right? You have three, this is called a water jug problem, right? Water jug problem, right? Water jug problem. Now you have two jugs like this. Now we are trying to create, right? Create a simple intelligent system. Okay. That is what we are trying to do, right? What I am trying to create is 1960s work, right? But that fundamental will help you to understand some basic concepts. And then we can develop based on that, right? So this is 1960s knowledge. Okay. So this is a 4 liter, let's say this is 4 liters and this is 3 liters. There are no measurement marks on these jugs, right? There are no measurement marks. Okay, so you can't measure. You have an unlimited water supply, right? You have unlimited water supply. That is an assumption. Okay, and you are free to throw away your water to the ground, right? You can throw away any amount of water to the ground. From that side also you are free. Okay, without using any other measuring equipment or any other can with some measurement marks on that, right? I want you to get exactly 2 liters, right? Exactly 2 liters on any of these jugs. My requirement is to get 2 liters measured, exactly 2 liters measured using only these 2 jugs, right? Now, if I ask you the answer to this question, right? How would you solve that problem? Just imagine how you would solve that problem, right? So now I'm asking you this question: how can I get 2 liters, exactly 2 liters measured using these 2 buckets or jugs, which do not have any measuring marks on them? You have an unlimited water supply and you can throw any amount of water to the ground. Right? Now I am asking you to solve this problem for me. Right? You are my agent. Okay, you are my agent. Now I am asking you the answer. Right? Okay, so you might now, start thinking of it. Right? You will think, okay, I'm going to fill this 4 liter jug. Right? There is one thing you can do. So fill this 4 liter jug. Pour that into the 3 liter jug. You get 1 liter remaining here. Right? You get 1 liter remaining here. Throw away these 3 liters. Put this 1 liter into 3 liter jug. Now you have 1 liter here. Right? Refill this 4 liter. And fill this 3 liter jug. Remaining of the 3 liter jug you fill using this. Then 2 liter added to this, it will make 3 liters. What is remaining here will be 2 liters. Okay. You told me a set of steps, right? I have done this exercise for several times, so I know that. Okay. So let me write down these steps for you. Okay. Fill the 4 liter jug. Transfer 3 liter to the 3 liter jug. Right? We don't measure and transfer, but when we fill the 3 liter jug, we transfer 3 liters to that. Right? Refill throw away water in 3-liter jar, right? Fill, now transfer the water in 4-liter jar to 3-liter jar. Right now it has 1 liter. Fill 4-liter jar. Right. Transfer water to the 3-liter jar until it's full. Right. What you have remaining in the 4-liter is the 2 liters. Now you have solved this problem. Right. Now I, as a human being, now I solve this problem and I wrote down the steps as well. Right. Now suppose you write a program. Now this is your algorithm. Right. This is your steps of instructions. You write a program. Right. Suppose somehow you have an actuator system as well, right, to do this. Right. You execute these steps and you get 2 liters fit. Is it intelligent? It is not intelligent. Right. What is intelligence is the way we found these steps, right? The way we found these steps is the intelligence we have. Right. Now suppose you want to train a software program, or you want to create a software program which can find out this answer on behalf of you. Like I wanted you to find out this answer, I want you to create a program to find this answer for you. So you kind of subcontract, right? So I asked you to find the answer for this problem, right? And I told you these steps also as the answer, right? So to show you that there is an answer. But replicating these steps, right? Replicating these steps does not give you any intelligence. That is just writing someone else's answer. What I want you to do is to find a way to make a program, right? To make a program to find the answer to this problem. Then that program can be thought of as somewhat intelligent, because it is able to find the answer. For example, if I give a different set of parameters, this time I give you 8-liter jug and 5-liter jug and asking you to measure 3 liters. Right? So it must adjust, right? So it should be able to adjust to that, the situation. Right? So that is the requirement. Okay. Now I want you to think about it. Again, I don't want a program. I don't want you to create a program to replicate these steps, right? That is not what I want. What I want is you to find out a program, a way of writing a program to find this answer for you and then for me, right? I'll tell you again why it is required to find a program which can find the answer for you. This is not the one and only way. There is another way. There is another answer to this problem. There are 2 answers, right? So if our intention could be like we can have 3 intentions. One is find an answer. The other one is find all answers, all possible answers. Third thing is find the optimal answer. Right? So we are trying to solve a problem. We want either an answer to that problem. We want all possible answers so that we can evaluate. Third one, we want the optimal answer, the best answer out of many answers. Right? I'm not saying that you can do all these things here in this particular context, but what I want is I want you to find a way to create a program to find the answer and all possible answers to this particular problem. Right? Can you do it? Now it is 10. I'm going to stop at this point. When you come next week, right, I want you to read a little bit about search and how to create a searching agent, right? How to create a searching agent who can search for an answer to this problem. Okay. Design a searching agent, right? Searching agent who can search for answers. I'll put /s here. Answers to this water jug problem. Okay. So searching agent. So that now I have given you a problem. You hand over that problem to an agent. That agent is capable of searching for answer, and if there are existing many answers, right, and give you those answers so that you can hand over those answers to. Okay, so that is your homework, not for marks, but for learning. But make sure you do it. Right? I need a bit of preparation from your side when you come to the class. In a truly transformational learning environment, I should not teach you here. I must tell you, okay, do this and come to the class. In the class, we will practice it. Okay, right. Any questions? So in this discussion, we have simple search, heuristic search, and advanced search using genetic algorithms, right? So after that, I will be introducing you to either neural network or fuzzy logic systems. Since we have a machine learning module later, we can take the discussion on neural networks and machine learning into that as well. Earlier, I used to discuss that in the class because the students, there were students who are quitting with the postgraduate diploma, but from this time onwards, we only have master students. So I expect you to do machine learning. So in machine learning class also, we can discuss about neural networks. So I can probably jump into other topics of intelligence as well. So let's see, right? Yeah. So agent to agent communication, yes, that is possible. So actually it's like this. Now we will take a use case on this agent to agent communication. Let me note it down here so that I can take the discussion next week. Agent to agent communication. What I normally do is I before the class I look at this recording's last bit so that I remember what I was discussing with you. So agent to agent communication, I will give you a use case next week. For the moment, you think about multi-agent systems, right? The basics of multi-agent system is this agent to agent communication and information exchange, right? So like we discuss and learn things, and we coordinate certain actions. Right, so agents can also do the same thing. So I will give you some examples next week about this agent to agent communication. If you want to extend our smart agriculture system to understand this agent to agent communication, think about a smart greenhouse, right? Smart greenhouse. Okay, so smart greenhouse, that's enough, right? So inside a greenhouse, right? So there are so many sensors, so many actuators. Can you put together all these things to create a better growing environment for these plants? A similar example could be smart buildings. Inside a smart building, the lighting, ventilation, humidity, and other odor and everything needs to be controlled so that the people inside the building feel comfortable, right? So if you need to create a smart building, you are going to require these kind of agent to agent communication. So for the moment you think along those lines, next week we will have a somewhat longer discussion on this agent to agent communication. I think that is required. You are correct, right? Okay, that's it from my side. Are there any questions? Any other questions? Right. So if so, I'm going to wind up at this point. So I'll see you next week. Hopefully by next week, the situation could have been better. Hopefully, right? Could have been worse as well. So let's be strong and let's try to face this reality and try to see how this intelligent system concepts can be applied to various problems that you see around, right? Okay, so have a nice weekend. See you next week.